What if I told you this tiny component decides whether your entire circuit works or dies? And now imagine this. The markings are gone. No color bands, no label, nothing. So how do engineers still find its value? Let's decode the hidden language of resistors. Now let's talk about what is resistor. A resistor is one of the most basic components in electronics. But don't underestimate it. It doesn't store energy. It doesn't generate power. It simply controls one thing: how much current flows in a circuit. Think of it like a narrow pipe in a water system. The narrower it is, the harder it is for current to pass. The most common way to identify a resistor is the color code. Look at this photo. This is resistor color code chart. This helps to find resistor value. Each color represents a number. Let's take a simple example. Yellow, violet, orange, gold. Yellow is 4, violet is 7, and orange means multiply by 1,000. So this becomes 47 times 1,000 equals 47,000 ohms. That is 47 kilo ohms. But here's where beginners get confused. 5-band resistors exist too, and they are used for higher precision circuits like medical devices and computers. But engineers rarely rely only on color codes. They use a multimeter. Set it to resistance mode, place the probes on both ends, and the value appears instantly. But here's something important most beginners miss. If the resistor is inside a circuit, the reading can be wrong, because electricity doesn't take just one path. It finds all possible paths. This is where real engineering starts. If resistors are connected in series, their values add up. If they are in parallel, the total resistance becomes smaller. So if you measure a resistor in a circuit and get a strange value, it's not broken. It's just sharing current with other components. A 10K resistor might look like 3.3K ohms because other resistors are connected in parallel. This is how engineers think, not just measure. But what if there are no color bands at all? Welcome to modern electronics. These are SMD resistors. They use numbers like 103. That means 10 followed by 3 zeros, 10,000 ohms. And if it's damaged or burnt, engineers don't guess. They analyze the circuit behavior itself. They ask one question: what should this part be doing in this circuit? Because in real engineering, you don't just read components, you understand their role in the system. A resistor is not just a number. It is a control mechanism inside a much bigger machine. Now it's your turn. If I give you a resistor with faded color bands, how would you identify its value? This is the resistor. Explain your method in the comments. I'll reply to the best one. See you in the next video. Until then, watch this video.